Perhaps the most common method in measuring or laying out horizontal distances is through the use of tape. It is widely used in the construction of buildings, dams, bridges, and a lot more. Taping involves the stretching of a calibrated tape between 2 points and reading the distance indicated on the surveyor's tape. The technique used in measurement and the precautions taken will define the degree of refinement with which tape measurements can be made. Taping may vary from a relative precision of about 1:1000 to 1:25,000 or better. When the ground is fairly smooth and the ground cover vegetation is light and low, the effort required to measure the distance between 2 points or to set a point ahead of some required distance is very minimal. In this fieldwork report, the surveyor will learn techniques and principles as well as some considerations to be made when taping a level ground and uneven ground. The first objective of this fieldwork is to develop the skills of taping the distance on a level ground where the tape is fully supported by the ground. Second is to acquire the skills of taping the distance on an uneven ground where the tape is only supported at the ends.
For instruments and accessories, we need the following: range poles, a measuring tape, plumb bob, and markers. For markers, we can use chalk for solid pavement or ground and marking pins in grass or other soft grounds. The people involved in this fieldwork survey are the range pole man, rear tape man, and front tape man.
To ensure the accuracy of your data, here are the things to remember when taping. Keep the tape on the line being measured. Mark each station accurately. Keep uniform tension on tape for each measurement. If pull applied while standardizing the length of tape and pull applied in the field are different, the correction for pull is required.
Choose an accessible and obstructed course to be measured by the surveyor on a level ground. Mark the endpoints by a chalk if it is on pavement or by a marking pin if it is on soft ground, and designate it as endpoints A and B. A range pole man holds the pole vertically and steadily during the entire taping procedure at B to keep the complete taping process aligned and straightened. The tape is stretched out on the ground on a straight path along A to B where the O end is held ahead. We should take note that O end is nearer B than A. The rear tape man is responsible for giving the signal to the front tape man if his path is straight, while the front tape man is responsible to pull the tape taut once the tape is aligned already. The front tape man gets a pin and sticks it vertically in the ground exactly opposite the 0 meter mark of the tape. Rear tape man holds one pin and the rest of the pins are held by front tape man. Both the front and the rear tape man lift simultaneously the tape and move forward along the line AB to measure the next tape length. By now, the rear tape man holds one marking pin which signifies one tape length. The procedure 4 to 6 is repeated to complete the next tape length measurement. Make sure that the rear tape man pulls the pin before lifting the tape to move on to the next tape length. The rear tape man holds 2 marking pins to connote 2 tape lengths have been measured. Repeat the same process until all the pins being held by the front tape man have been used up, which signifies 1 tally. 1 tally is equal to 10 tape lengths. After a tally has been accomplished, the rear tape man returns all the 10 pins to the front tape man to proceed in measuring the length of the course. We should take note, 1 round is when all the 10 pins are now being held by the rear tape man. Repeat the same procedure if more than 1 tally is needed. Upon reaching point B, the partial length must be measured accurately up to centimeters by the rear tape man, while the front tape man is holding the 0 mark at B, and both them are holding the tape taut. The number of small pebbles in the rear tape man's pocket now indicates the number of tallies made. and the number of pins in his possession indicates the number of additional tape lengths. This is recorded in Table 2.1, taping over smooth or level ground. To compute for the total distance, get the total number of full tape lengths and then add the partial tape length to the product of the length of one full tape length and total number of full tape lengths. To compute for the mean distance, determine the sum of the total distance, then divide the sum by the number of trials. To get the relative precision, determine the probable error of the mean, then divide by mean distance and reduce the numerator to unity to determine the relative precision.
Taping over uneven ground. The same course is measured, but this time the tape will be unsupported by the ground and must be held an eye level distance above the ground. Both the rear and the front tape man hold a plumb line over the center of the hub. The front tape man must hold this plumb line an arm length away from his body for the rear tape man to clearly see if it is aligned in the range pole at B. Once the rear tape man approves the alignment, the front tape man holding the 0 mark pulls the tape dot and drops the plumb bob on the ground. This will mark the ground with a dent to guide the front tape man where he must place his marking pin. This is to be done continuously until point B is reached. Note that the partial length must also be measured as in Procedure A. The course is measured back and forth to complete the number of trials required by the professor. Tabulate the data in Table 2.2, taping over uneven ground. To compute for the total distance, get the total number of full tape lengths and then add the partial tape length to the product of the length of one full tape length and the total number of full tape lengths. To compute for the mean distance, determine the sum of total distance, then divide the sum by the number of trials. To get the relative precision, determine the probable error of the mean, then divide by mean distance and reduce the numerator to unity to determine the relative precision.